Okay, let's do three exercises in this short video. We're trying to graph some rational functions. The first function is the problem 11. What is the section number? This is the section graph of rational functions. So if I don't have section number, it doesn't matter. Okay. So problem 11, r of x, the rational function is 3 over x squared minus 4. Okay, we're going to graph this. First, you find the domain. The domain is from negative infinity to negative 2, negative 2 to positive 2, and 2 to infinity, right? We just remove plus minus 2. We remove plus minus 2, right? So x minus 4 cannot be 0, x squared cannot be 4, so x cannot be plus or minus 2. Okay, and this is the lowest term, in lowest term. In lowest terms. And then you can find the vertical asymptote. Vertical asymptote. One is x equal to 2, one is x equal to negative 2. And then you find the horizontal asymptote. Horizontal asymptote, because the degree of the numerator is strictly less than the degree of the denominator. So y equal to 0 is a horizontal asymptote. I didn't do this in the order, so I will collect everything we need. So it is a xy intercept, y-intercept. Y-intercept is r of 0. You let x be 0, you get y-intercept is negative 3 over 4. X-intercept is r of x, which is 3 over x squared minus 4 equal to 0. R of x equal to 0. But this equation has no solution. Okay, so there's no x-intercept. It is possible the graph has no x-intercept. No x-intercept, the graph does not intersect. You see, no x-intercept. Also, this y equal to 0 is a horizontal asymptote. So the graph does not intersect the horizontal asymptote. Okay, and what else? No, there's no other things. Let's try to sketch it and see if we need more. So this is negative 2, this is positive 2. And negative 3 over 4, negative 3 over 4, negative 1, 1, possibly here. Okay, the positive negative infinity, right? On the left side of x equal to negative 2, on the left side of x equal to negative 2, let's choose x is negative 2.1, left side. Negative 2.1, r of negative 2.1 is 3 minus negative 2.1 squared minus 4. So it's a 3 over 2.1 squared minus 4. 2.1 squared minus 4. This number is greater than 4. Minus 4 is greater than 0. 3 over 0, positive 0 is greater than 0. So I need to know the sign is positive. On the right side, of x equal to negative 2, let's choose x equal to negative 1.9. Then r of a negative 1.9 is negative 1.9 squared minus 4 is 3. This is a 3, number 3, not 2. So number 3 over 1.9 squared minus 4. This is negative. 1.9 is less than 2, so its square is less than 4. So you get negative. It means On the right side, it approaches negative infinity. On the left side, it approaches positive infinity. Okay? And similarly, for the x equal to 2, on the left side of x equal to 2, left side of x equal to 2, x is, for example, 1.9. So you check 1.9. It's negative. On the right side of x equal to 2, x is 2.1. Let's choose 2.1. 2.1, r of a 2.1 is 3 over 2.1 squared minus 4 is positive. Okay, so let's check. Eventually, the graph will approach 0. But I don't know positive or negative, and remember the graph does not cross it, does not cross the line. So on the left side, it will approach positive infinity, so it's here. It's here. It will approach to 0, but it does not cross it, so you will draw it like this, right? You don't have other way. You don't make a wave. Don't make a wave. Without any reason, you don't make a crazy graph. So positive infinity, and it goes to 0, so it has to be like this. Okay, and of course, you don't draw this way, because if you draw this way, it looks like the graph will cross the horizontal. It looks like the graph will cross the vertical asymptote, which is impossible. So you have to draw it this way. The other way is not possible. It looks bad. Okay, and in the middle, it goes to negative infinity and negative infinity. You see, right side of negative 2, negative infinity. Left side of positive 2, negative infinity. And here's negative 3 over 4. So just connect them. The horizontal asymptote only happens when x approaches negative left side or right side. In the middle, you don't consider anything about the horizontal asymptote. Okay? In the middle, you just use smooth curve to connect them. On the right side of 2, you see, on the right side of 2 is a positive, so it's a positive infinity, and you just check how you do it for the left side, you do it for the right side. Okay? And also because this function is an even function, we didn't emphasize this function is an even function. The graph is symmetric about the y-axis. So it looks like this. It's good. Okay? You see, how do we do it? We first determine the xy intercept, and we have xy. We determine the xy intercept, only y-intercept, no x-intercept. So you cannot cross the x-intercept. You cannot cross the x-axis. And you have a vertical asymptote. The graph does not cross vertical asymptote. Whenever it approaches it, it will be like very smoothly approach. You cannot go this way to approach it. Okay, and when it approaches horizontal asymptote, it also smoothly approach horizontal asymptote. Okay, and if over any finite interval, you don't consider anything about the horizontal asymptote. For example, this is finite interval. You just use smooth curve to graph it. And also on the vertical, around the vertical asymptote, left side, right side, you need to determine the sign, positive or negative. You just choose some close number. Here's negative 2, you choose negative 2.1 or negative 1.9. Right? You determine the negative infinity or positive infinity. Because close to vertical asymptote, you will get infinity. The question is it a positive infinity or negative infinity? Okay? So this is a graph. If you are not satisfied the graph, you can get more sample point. For example, you can choose x equal to negative 3. And try to evaluate r of a negative 3 is a 3 over negative 3 squared is 9. 9 minus 4 is a 5. So it's possibly at negative 3, it's a 3 over 5. So it's here. And the positive 3 is also here. You see here, it fits, more or less it fits the graph. Okay? If you don't get idea how to sketch it, just choose more sample point over that interval and try to compute it. But without the support of a sample point, you just use a smooth curve to sketch it. Don't make any crazy curve. The graph of a rational function does not allow crazy curves. So for example, like this, it goes this way, it touches this point, and between them, you don't see any special point. You see, between -2 and +2, there's no y-intercept, there's no x-intercept, there's no vertical asymptote, nothing. If there's nothing special, you just sketch it smoothly. Okay? Okay, this is our first example, 11. Let's talk about the other one, 12. We graph the function x, r of x is equal to 6 over x squared minus x minus 6. First domain. Domain means x squared minus x minus 6 cannot be 0, which means x minus 3, x plus 2 cannot be 0. So x is not equal to 3, and x is not equal to -2. Just remove -2 and 3. This is domain. And then it is lowest term in lowest term. And you have vertical asymptote. Vertical asymptote is x equal to -2 and x equal to +3. When you talk about asymptote, it's not -2 or 3. It's x equal to -2 and x equal to +3. It has to be this line equation, not just say, okay, -2 is a vertical asymptote, 3 is a vertical asymptote. That is wrong. A number does not give us asymptote. The line gave us asymptote. These two equations represent two vertical lines. And the horizontal asymptote. Again, the degree of the numerator is less than the degree of the denominator. Y equal to 0. You see here, y equal to 0 is a horizontal asymptote. And xy intercept, y-intercept, x is 0, r of 0. R of 0 is -1, right? This is 0, this is 0. 6 over -6 is -1. X-intercept is r of x. R of x is 6 over x squared minus x minus 6 is equal to 0. But a rational function is 0 if and only if the numerator is 0. Numerator 6, never 0, so no solution. So no x-intercept. Okay, so this one has no x-intercept, and 0 happens to be the horizontal asymptote. So the graph does not intersect horizontal asymptote. The graph does not intersect the horizontal asymptote. Okay, and based on the previous example, we need to study the behavior, like the sign, positive and negative infinity, close to the vertical asymptote. Let's do it right now. On the left side of x equal to -2, we choose -2.1, -2.1, and then you check the sign. We don't need the value, we just need the sign. -2.1 squared minus -2.1 and minus 6. Well, here you really do some computation. -2.1 squared is 2.1 times 2.1 is 4.44. 4.44. Minus minus is plus 2.1 minus 6. Okay, so the sum is more than 6. Minus 6 is positive. Again, I don't care the value. I care if it is positive or negative. So this is a positive. Okay. On the left side, this is left. And on the right side of x equal to -2, we choose x equal to -1.9. -1.9. -1.9 square minus -1.9 and minus 6. Oh, let's check 1.9 times 1.9. 361. 3.6 and plus 1.9 and minus 6. This sum is less than 6. 4 plus 2 is 6. This is a 3. This is less than 2. So the sum is less than 6. The difference is less than 6. So we get a negative. Okay, so we studied left and the right side of x equal to -2. Then on the left side of x equal to 3, left side x is a 2.9. So r of a 2.9, 6 over 2.9 square minus 2.9 and minus 6. 2.9 times 2.9, 26. And 5.8. It is what? It is 9.41. Okay, so it's a 6 over 9.41 minus 2.9 minus 6. 9 minus 6 is a 3, so it's bigger than 3. So this is positive. Positive, negative. Let me check. It's supposed to be negative. Where am I wrong? 2 plus 5 is 7. 7 plus 1 is 8. This is 8.41. Yeah, my bad. 8.41. Is this right? Yeah, then this is negative. 8.41 minus 2.9 minus 6 is negative. So on the left side, right side again, sorry, right side of 3, x equal to 3, you can choose x is a 3.1. So r of a 3.1 is 6 over 3.1 square minus 3.1 minus 6. 3.1 times 3.1, 9.61. And this is a positive. Okay, this becomes positive. Good. Once we get this, we're going to sketch the graph. Okay, so we have a -2, 1, 2, -2 vertical asymptote, and 1, 2, 3 +3 vertical asymptote. And on the left side, it's positive, so it's positive infinity. It does not cross x-axis, so it looks this way. On the right side, on this part, it's positive. Right side is positive and approaches infinity, also this way. And between them, in the middle, this is -1, the y-intercept. It goes to infinity, infinity. So you can just sketch it this way. And that's it. That's it. That is the graph. That is the graph. If you want to make it more precise, just choose some more point. For example, here you can choose -1, 1, and 2, and evaluate the function. Evaluate r of x. You evaluate r of 1. It's -1 also. Yes, R of 1 is -1. Here's also -1. R of 2 is -3/2. This part. R of -1 is what's this? -3/2. Yeah. So, well, it's more or less like this. It's not too bad, right? It's not too bad. Okay. So that is the example. There's one more similar problem. Oh wow, it's not similar. It's a little bit harder than it. Let me do it. Okay, let me do it. 21. From the same section, 21. R of x is 3 x minus 1 x squared minus 4. If you factor x squared minus 4, you will get x minus 1, x minus 2, x plus 2. Okay, and then you go through the whole thing. I do not want to write all the steps. I just tell you how to sketch it. You get a -2, you get a +1, you get a +2. You have 3 vertical asymptotes. 3 vertical asymptotes. And then you have to, the long part will be the study of the behavior around the vertical asymptote. You will check that on the left side of the x equal to -2, right side x equal to -2, left side x equal to 1, right side x equal to 1, left side x equal to 2, right side x equal to 2. You have to check everything. When you check, after you check everything, you will see that horizontal asymptote is y equal to 0. And then you will see that on the right side of x equal to 2, for example, you choose 2.1, you will see it's a positive. So it looks like this. And on the left side of x equal to 2, this is 2, this is 1. This is -2. You just check the R of 2.1, you will see it's positive. And if you choose R of 1.9, you will see it's negative. And you will, if you check R of 1.1, R of 1.1, you will see it is still negative, right? You check the value R, the evaluation x at 1.1. Okay, then you will see it's negative. So it's this way. And okay, it does nothing. So it has to be this way. Right? You go to negative infinity here, negative infinity here. Understand me? So this value is negative. This value is also negative. So you go to negative, it's like the holder, some holder. And if you check the on the left side of r equal to 0.9, x equal to 0.9, r of 0.9, you will see it is a positive. And if you check r is on the right side of a -2, -1.9, it's still negative. So, and the y asymptote, y intercept is a 3/4. So it's some place here. So it looks like this. And then on the left side of x equal to on the left side of x equal to -2 is negative, and the graph does not cross x-axis, so it looks like this. Okay, so just check different values and make the graph either approach positive infinity or approach negative infinity. If between those two vertical asymptotes there's no special points, then you just make the graph smoothly and connect them. Approach negative infinity, approach negative infinity, just connect them. You can put it lower or higher. It totally depends on additional evaluation. You can check that the evaluation R of 1.5 if you want to make it more precise. R of 1.5 will tell you where this point is. It could be higher or lower, but be careful, this point can never be above the x-axis, because if you do that, you will cross x-axis, which is not possible. This function has no x-intercept. And every place, you just check the sample point. With more vertical asymptote, you will have more sample point to check in order to know that you approach positive infinity or negative infinity. It is a tedious job. But technically, I can show you how do you check it. I don't want to compute. For example, this R of 1.9. I know it is negative. Why? Check here. 3, 1.9 minus 1, 1.9 minus 2, 1.9 plus 2. This is positive. 1.9 minus 1 is positive. 1.9 minus 2 is negative. 1.9 plus 2 is positive. A positive number times negative number times a positive number is negative. So I even don't compute it. If you already fact it, I don't compute it. I can see if it is a positive number or negative number. And similar thing, if you put 1.1 here, you can also determine it's a negative number. That is a way to quickly determine it. It's not like here we really do the computation. Okay, you can also use this trick to determine the sign of the infinity. Is it positive infinity or negative infinity? Okay, so this type of problem is sometimes tricky. You have to clearly sketch the graph, and sometimes you have to consider more sample point if you want to make the graph more precise. But the big picture should be like this. Okay, so do the exercise, send me email if you have questions.